Hey there guys, and welcome back. So, it has been nearly 2 weeks. It was 2 Mondays ago. So we're not quite at, or I guess one Monday. Yeah. It was the Monday before last. Anyway, that we last talked, if I recall correctly. If I do not recall correctly, then whoops. Anyway, basically what happened is last time we talked about designing the box, whatever, the keypad, the replacement, the updated version of this, which I was working on, and see previous projects video where I discuss all the intricacies of what went wrong with this. Regardless, I was thinking about ways to make the rails work, because honestly there's 1.5 million different ways to make that work. And by, let's see, that was like Monday, right? So by Wednesday I had a few pretty interesting ideas cooked up, and I was going to go ahead and stream. But then I decided, you know what? I better make sure that the keypad actually works. I better put up a little prototype of it and make sure it's actually working and I haven't screwed anything up. So, let me just pull this up really quick. And again, one of those things, that's what this keypad would be for, so I don't have to go looking for it. But this is what I put together. So this was the Arduino, obviously, over here. My wires, this is my bus. Well, technically speaking, this is the bus right here. This is just connectors getting over to there because I didn't have wires long enough. Regardless, point is that this is the bus. This half over here would be the in bus, and that half over there would be the out bus. You can see little jumpers that I have across here for the actual bus part. And then we have 2 more wires that would be the serials, and those would daisy chain. So they would go over to, right here is the 165, and over here is the 595. So they would go here first, and then from here, from the output on this one, or from the input on this one, and the output on this one, the 595's output and the 595's input, that then would go through the other half of the bus up to the second expansion in this example. So I put this together, make sure everything worked, and it didn't. There were a few things that were just plain not working correctly. And I went, okay, after trying to debug it a little bit, I figured I needed a much better idea of what was going wrong. A wider view really is what it comes down to. So I went ahead and built just a single board right here. So this is a complete expansion right here. We got 8 buttons and 8 toggle / indicator lights right here. This would be exactly the same thing as this. Obviously the buttons are different and the LEDs are slightly different, but it's effectively the same exact thing. And the button inputs I had a minor problem with. That wasn't too difficult to figure out, but basically I just had a couple wires in the wrong places, and I needed to go back over to the data sheet to make sure I understood how everything worked. That was maybe 2 days, not that big of a deal. I'm trying to think, because they're actually, I feel like I did something. Oh, that's what it was. Sorry. Back up. Before we even got to this part, before we got to the buttons were, again, a day or two just sorting out what I had wrong there. Before we got to that, I was bricking the micros. So, if you recall my Corona box that I made, spinner, okay, voice pack thing, soundboard spinner. I had bought several micros because I had accidentally broken a couple of them and I needed to get replacements. So I have several micros sitting around, pro micros sitting around, and I bricked 3 of them before I finally figured out what was going on. Basically, this is using the keyboard library. The keyboard, on its begin, it tries to communicate with the computer to let it know it's a keyboard. And one thing that it probably tells you in the documentation, but I did not look at since the last time I went and put this together, which was, again, like probably 1.5 years ago at this point. Basically what happens if you start out with the keyboard.begin, okay, to begin serializing it and to get the driver on the computer to recognize it as a keyboard input. Well, if you then start spamming that keyboard input, which is what I was doing here, basically because my wires were wrong, I was spamming the keyboard input with a whole bunch of inputs. that would make the computer fail to initialize the keyboard. And at that point, the Arduino cannot actually finish initializing as an I/O device, as a HID rather, human interface device. And because it can't finish that part, it's an undefined USB component. And at that point, you cannot actually program the micro. So that is what this button, I mean, this is the reset button right here that I added. But the fact of the matter is that it's kind of useful for other things. However, for debugging purposes, it's kind of useful. I should just clarify. However, double clicking this, resetting the board, and then resetting the board a second time will take you into the quote-unquote slow bootloader, which then will give you a chance, so long as you're quick, to flash a new program to the micro. So basically what you have to do, in case you run into this problem, is you need to make a blank sketch, nothing on it, hit the upload button, then double reset to get yourself this small slow bootloader while the program is compiling. That way, when the program is done compiling, it immediately then uploads, because if you do not have the program compiled by the time that this finishes rebooting and going through the slow bootloader, then it will be too late. Then the USB will no longer be recognized, again, unrecognized USB device, and you won't be able to upload to it. You have to get it. They say it's 8 seconds, okay? I swear it's less than 8 seconds. So hit the upload button first, double tap your reset. That will get you a slow bootloader, and that should give you enough window to get a blank sketch onto the micro so you can reprogram it. Now, how do you fix that? Well, obviously, you just got to put a delay in. So you go keyboard.begin and then delay for, I think it's like 300 milliseconds is what I figured out. And that is enough. I'm pretty sure I played around with it a little bit, if I recall correctly, and it was somewhere between 250 and 300 milliseconds what you need to finish initializing this as in keyboard input, HID keyboard input. So yeah, that was actually 2 days of lost because I kept on breaking these things, and then I had to, spam the reset button and get them unbricked. And then we moved on to the buttons. Again, buttons were pretty simple and straightforward. The one minor thing that's really slowed me down here on the buttons is that the shift in Arduino can't talk. Arduino.shift in, which actually isn't really Arduino.shift in, but regardless, let me pull that up for you. So over here, what you'll notice, if you're interfacing with a device that's clocked by rising edges, which is what we are doing. Both the 595 and the 165 are rising edge clocks. You'll need the pin low before you call shift out. I was doing that and it was still not working on shift out. It works on shift in, and actually you don't even need to do that in shift in. You can actually shift in without. I'm saying shift in, shift out. I'm getting these backwards. It's the same exact problem on both of them. So that's regardless. The shift out and the shift out in method, if you look at them in the source code, work basically the same. Regardless, point is that shift in rather. Here. Shift in. Shift in. There we go. Same exact line right here, as I was saying. So I was doing this and it still was not working on the buttons. And therefore I had to write my own shift in based on, well, one of those things. I didn't even really write my own shift in. If you Google it, you'll find a Arduino forum post where a guy did the same exact thing. So I just copied his code and then modified it a little bit to use my variables to make life more easy. So that was the only little hiccup on the buttons, and the only thing that really caused the buttons to take about 2 days was figuring out that the shift in, because his buttons were getting the input from the buttons, so the shift in was a bit foobarred. So at that point, we're up to 5 days out of the last 12 days, which is what it's been. So actually, that's 7 days technically. So yeah, 7 days out of the last 12 days. So what was the problem with these guys? So when I started running into problems here, is basically all the way back here, I started getting the idea that I should, but by the time I got to the buttons, I decided I had to look at the datasheet. So I went and mapped out the datasheet, and we can hop on over to the pictures I took. The pictures aren't great quality, and that is definitely my fault. There we go. Please, thank you. All right. So anyway, I went ahead and just made notes on how the 165 and the 595 worked. And according to what I read on the 595, the big problem that really slowed me down is that it said that you could put the output enabled into the high impedance state, and then that would not mess up any of the serial. And actually, let me go ahead and just swap us over here, because I have the documentation up. And 595 is here. So all the way down here, right here, the serial output is not affected by this control unit. So as I understood this, put into low allows the outputs to be latched to the present outputs, and high forces to be QA/QH into a high impedance state. As I understood this, I thought this meant that you could, because if we look at this, you'll see that there's a shift register, a latch register, and serial outputs. Those are three different areas. And again, referring you back to this thing that I made, you can see I have serial, latch, and outputs here. So as I understood it, there were three different areas basically to this device. And therefore, by setting the output enabled to high, back to there, back to the data sheet, I could change the other registers, the shift register and the latch register, without changing the output. That's how I understood this statement right here. So for the past 5 days, I've been trying to figure out why the heck everything is not working here. And the worst part about all this is that if I was wrong about this, what I would expect is I would expect to basically either not have my data change or have my data constantly changed. And the worst part is that I was actually getting a mix of that. Sometimes the data was just plain wrong, which would suggest that there's some kind of clocking / serial mess up, which again, simply having this in the high state, the output enabled in the high state, should not be interfering right here. The serial output is not affected by this control unit. So that should not be screwing up how I receive data on the 595, but evidently it was, because I was getting wrong data. And intermittently, the output was not even changing. So I would cycle the output enabled pin from low to high, and that would not even change the data. So again, across 5 days, one other problem that I had, actually, let me just verify for the sake of clarity. I also forgot to pull the reset pin high. I had it floating. So at first, I was also getting a little bit of flickering, which was really weird, and some randomness. However, I figured that went out pretty quickly. So that was not a problem at that point. That was like within the first day. So I keep on saying days here. Keep in mind that I'm only spending like an hour and a half on this thing per day. So it's not like I'm spending 5-8 hour days fixing, the microcontroller and the buttons for those first 5 days. So regardless, point being is that this was a really quick fix. I realized, oh crap, I forgot to pull the reset button high. This one, however, again, for what was going wrong with this, and for the record, it just needs to be held low. You can't even cycle it from low to high at any point. Like, for example, in my code originally, I set it low, I set it high so that the output wouldn't change, and then changed the changed the shift register, then latched the shift register to the latch, And then after shifting low to high on the latch, I then shifted the output enable to high. That was the first way I had to set it up. Then, after that was not working, I just left the output enable high. Left the output enable high for everything. Nothing really worked. Again, had similar problems. Left it low for everything. Nothing really worked. For some reason, it just has to go to ground, is what the short answer here is. I could not, for whatever reason, having it set up with the Arduino, I just could not get it to work without it being permanently tied to ground. So that was really frustrating and annoying, but here we are. So I'm going to go ahead and toss the camera on. We'll go ahead and plug this in. Boom. And go ahead and just start. I've got all the buttons set up as toggles right now, so just running through this. And it looks like I missed 3. There we go. And then we can come back down. I'm doing this upside and backwards, so I can't actually see where the buttons are, for the record. And in theory, I've got these guys here just to represent. In theory, I could take this and just run it over to here, and it should work. There's no reason I can think of at this point, now that this is working, that this shouldn't work. Also, let me just hop on over to Notepad really quick. Get Notepad up. Hop over to desktop. There we go. And nope, I'm not. Click into Notepad. There we go. And you can see as I push the buttons. Well, I guess I should have set this up so you could see both at the same time. And furthermore, the screen is a little cropped, but as I push buttons on here, it sends signals back through the keyboard to activate whatever. So again, everything is working at this point, and we are ready to move forward. So, next topic is VS Code. Alright, VS Code is up. And, I was going to switch over to the actual VS Code window, but it looks like that has been forgotten about. Not that one. Derp. Where's VS Code? VS Code. There we go. Alright, so anyway, back when I was troubleshooting all this, I had my original code here, and I decided to just start a new file and pull things out as I needed it as a way of debugging. So as I needed stuff, pull it from the old file into the new file and build my way up from that. Most of the code, like 80% of the code is, maybe 70% of the code. 70% of the code is still the same as it was before. I don't recall if I showed that in a previous stream, but all it basically comes down to is obviously put this low. That latches the input, as you can see here. So this latches the input into the 165. We give it a second. I've seen this in sketches by other people, so I decided to just include that as well to be safe. Latches to high. That then takes the inputs that are now on present, the inputs that are now present at the gates, that stores them into the the shift register by going high, and then we handle the button states. Handling the button states goes ahead and right here. For each of our expansions, we shift in from the input, and then we just look at each of the buttons and handle whatever they're doing right now. So it's pretty simple. One of those things, I don't feel a need to go through all the code right now because, again, everything's pretty simple. So we will not worry about that till later. This is then for the 595 right here. We latch low, output the toggle states, latch high. Very straightforward. And then I'm just running this 100 millisecond delay here. It's probably not necessary, but it kind of gives you like a pseudo D bounce anyway. So I don't think it's a bad idea to include. I did at one point have debounce as an option over here, but I got rid of that. In case you do not remember, or if in case I never really went over this on stream from the last time we were doing this, this config.h is how you set up the expansions. So here we define expansions. I'm just using one for the demo, so that's one. The number of keys on each expansion, and then we've got a button struct, okay? And that is how you define what each button does. This state you don't touch, that's just internal for whether or not it's pressed or not right now. But first thing up, is it toggleable? Does it do an alt modifier? So this is, again, because this is a hotkey macro pad, include alt plus the ASCII code or not, control plus the ASCII code or not, and then the ASCII code itself. Again, right now I just have the numbers set up right here, and obviously you have the same number of buttons as you should have the same number of buttons as you have key counts. As you can see, expansions key counts. So when you set this up, when you configure your expansions, that's how you do that. You just match the number of buttons for each expansion, and you match the number of expansions based on what you supply here. And the reason this is all necessary is A, to help us keep track of the toggles for any buttons that need toggles, which are initialized right here. So that helps initialize the toggles right here. We're just initializing to 0, which is all not toggled. We can consider including some persistent memory in here, but that seems like a bad idea to me, so we probably won't, honestly, because that does seem like something that could have be a problem in the future. Basically, if you unplug and plug your macro pad back in, right, and you have, let's say, mute toggled on for your streaming software is the idea. When you unplug it and plug it back in, if it thinks it's already muted but you changed mute for some reason, heck, I mean, if you just close the streaming app in between streams, and then keep unplug and plug in, you know what, it made a lot more sense until I started trying to explain it, and then for some reason I'm confusing myself here. Anyway, you understand what I'm trying to say. Hilarious as I may be saying it. Regardless, this keypad order. So as you can see, it can be defined as MSB or LSB. Basically, the way you wire up the keypad will determine whether or not you need it to be LSB or MSB. So if we come back to the camera just to demonstrate, this is button number 1, and that does the first toggle over here. This is the button all the way on the left if I have this actually facing me. Again, it's facing away from me right now, but this would be on my left. Therefore, because I read left to right, I would expect that to be button number 1. On this keypad, okay, I would expect the top left to be number 1. So 1, 2, 3, 4, 5, 6, 7, 8. Depending on how that's wired up on the back side, I may have wired that up backwards so that LSB would be 1, 2, 3, 4, 5, 6, 7, 8. We don't want that, right? So at that point, because this is already wired in and I can't really change this, we can just swap the order in the firmware. And now, even though this is the first input on the shift register, we can actually read most significant bit first, and we'll be reading this one instead. So that's how that works. That's what that feature does. And I think that's everything important. Again, the only thing that should need to be configured is this file right here. Nothing over here from this point onwards should be modified. I'm pretty sure this is permanently how this is going to be forever, because this, again, should just work off of the configure. So, we are going to hop back to camera, and we are, now that we have all this out of the way, we are going to talk about Rails. Now, it's one of those things. Last weekend had all of this been taken care of, tonight I would have just said, hey, some minor bugs, fixed them, let's move on with the rest of the build. Unfortunately, because I just spent all that time going over all the bugs I fixed, and because I've spent so much time over the past 2 weeks not thinking about the design, it's one of those things I kind of just want to spend the rest of this stream talking about the different rails that I came up with, and that's it. Had everything not gone to crap and it hadn't been 2 weeks since I last thought of this, then I would actually be in Fusion right now, and we'd be drawing them up in Fusion. But because it's been 2 weeks, again, I'm rounding 2 weeks here, but because it's been about 2 weeks since I last thought about this, I just want to take it easy, and we'll just whiteboard some of these rails I was thinking about, since they're not as fresh as they were in my mind last week, basically. So, originally, let's just start out with the original idea that I was talking about 2 weeks ago. We were talking about having either some rods or a single rod, and having a persistent connection to wires running along those rods. Okay? That's what we're talking about. And using brushes slash, flexible, spring steel, whatever. Making sure we have constant contact. And where this gets important is I was thinking about other methods that we can use to combine extensions together, which for the record is what I mean by rails, okay? I was thinking about other rails like that, and I realized that the comment I made when I was talking about these is not actually accurate. And the comment I made was that it doesn't matter if we lose power halfway through here, because the I/O on these should be persistent, and that doesn't necessarily matter. And I realized that that is actually wrong. And that is because we are constantly sending a clock signal through here. Well, not constantly. We're not constantly sending a clock signal through here. But at an extremely fast, once every 10th of a second, we are sending data in and out over these rails. And it takes more than a 10th of a second to take the expansion and expand it. To take one of these guys and slide it over so that we can get to more of it. And for that reason, we are going to interrupt this, and now our data, instead of coming through like this, is going to come through like this, with just some random bit here on the end, which is obviously wrong. So now instead of 1001 for the first 4 bits, we're going to have 1010. And that's assuming that the signal doesn't get even wonkier than that, which it can. So basically, the data corruption that could come from that is a bit of a problem. And therefore, what's probably going to happen right now, we are still at 7 wires on the bus. I'd given us space for 8 wires because 8 wire is a nice round number. 7 wires where we're at. We can add an 8th wire is one idea that I'm considering, such that for every expansion, and I'm just going to draw them like this, if it is in motion, this wire gets cut. And then when it reaches the full extent of its motion, it has another connection point that it can latch onto. So the Arduino can look and check to see if any of these guys have a broken connection because the wire is not making a full loop. And it can say, okay, that's a broken connection right there. I'm going to stop processing data. I'm going to stop sending and receiving inputs, outputs. And we'll just wait until this is live again. And because expanding and collapsing this keypad happens very rarely, it really should not be that big of a deal. So that is an idea to get around this. And what that also means is that these expanding and collapsing features do not have to be constant access. They can be in such a form that so long as it is done connecting, so that, let me change how I'm saying that. It is connected at the beginning, disconnected in progress, and then reconnected at the end. And that is for all of the wires. Everything on the bus can have an intermediate state because we're only checking one of these wires for a full wrap connection. So all of them, any of them, can go into a blank state and then reconnect later on. And for example, one of the ideas that I thought about to roll on into that is, I was thinking it might be kind of cool if we had some kind of cam shape. Okay, so we're pivoting around here. We have our box right here. So this is the lower box. The upper box starts out right here. Okay, and then because of the cam shape, it ends up somewhere over here. Now, this particular cam shape, its placement and how it looks is going to be important because, as you can see right here, if I just spun this cam like this, well, it's still overlapping any buttons I might have right here. But it's an idea, and I kind of like that. I kind of like the feel of it. I kind of like the fact that if it's some kind of cam, then it doesn't have a linear motion, right? It has some kind of arc to it, which is more interesting. The one problem that design has, is that the point of this whole entire system was that it is theoretically extensible forever, infinitely extensible, because the 595s and the 165s can be daisy chained, and therefore we can just clock in 50,000 bits. By clock in, I mean shift in 50,000 bits and shift out 50,000 bits. Does that get to be pretty slow as you get further on? Sure, but at the same time, how many of these are you really going to have? Are you going to have 500 buttons sitting in front of you for your deck? Probably not. So it's probably not practically a problem. I'm sorry. The slowness is probably not practically a problem. The way they uncollapse and collapse may be a practical problem, may not be, may limit you more or less. The other interesting problem with that design is that it would have to be pretty interesting on the way it works, because just going off of a single hub here, you figure each one then has a similar, or it would have to have some kind of unique, and it seems to me like we just keep on going in a circle. Now, maybe that's all right, but it seems also at some point that we'll end up over top of the first one, depending again on what this arc looks like. I mean, again, we can play with the shape of such a cam if we would like to, and maybe it ends up doing something like this. Imagine all those are symmetrical all the way around, symmetrical shapes. Although, again, maybe it's not symmetrical shapes. Maybe each cam is different, such that, you know, it gets you different places. Anyway, that was an idea that I thought of that was pretty interesting. I kind of like the idea of. However, one other problem, similar to the ones that we're talking about, but in a different axis, I should say, is my conception of this is that they're stacked up on top of each other. And that means that when we expand them out, to some degree, we are going to have them floating in midair. And they don't weigh hardly anything. Each of these expansions is going to weigh basically no grams at all. But you are going to be pressing on it, and that can, cause some amount of strain on the hinges, could deform over time, may not actually be a problem, may be a serious problem. One other thing to keep in mind is that I did say that these should end up very, very skinny. I was talking like 5 millimeters last time. I kind of forgot that the shift register may make it more like 8, but it's still going to be relatively skinny. Therefore, the height on stacking them up is not going to add up as quickly, right? It's not going to get that big that quickly. So again, I'm just spouting out design considerations as we go here. Next rail type that I was thinking of. All right, so I know I had 3 that were pretty good ideas, and I am forgetting the second one. I am only remembering the third one right now. So we are going to go ahead and move forward to the third one. I'm starting to think that maybe the second one was just a version of the third one, but I don't think that's correct. Oh, I know what it was. I know what the second one was. So there's 2 versions of the second one. One version is not very viable. The second version is not very viable, but is pretty cool. The first version, however, is viable. And that is that relatively viable. There is a problem, but we might be able to figure out the problem. We might be able to solve the problem. And that is magnets. So you have all of these pads, right? And you can just have them sitting wherever, and then you have your main pad. And you take these pads and you can tile them out basically however you want. And the one problem with this is that we would have to figure out a system for determining which pad goes first. The fact of the matter is that the user does not necessarily need to know which pad is first. That is the saving grace of this, because the user only cares about what buttons are being pressed, and we can probably figure out some way to figure out which expansion is which, and therefore which buttons are being pressed. I'm saying this in very vague terms because I did not put a huge amount of thought into this, because I thought it might be just too difficult, but it's one of those things. Over time, I'm kind of warming up to it. The more difficult problem with this first version is that in the software, which I just showed you in the firmware, we have all the expansions and predefined, and we predefined the array, and we predefined how much we're shifting in, and all that then has to happen dynamically. We dynamically have to update the number of expansions that we're handling. We need to dynamically update where things are being shifted in from and how many to shift in as we go. And when we toggle the buttons, when we activate the buttons to do the button macros, all that has to happen at that point dynamically. Again, I think there may be a way to get around that. Well, I'm pretty sure there's a way to get around it. It is difficult, though. It is a difficult firmware problem, though, not a difficult hardware problem. This is actually a significantly easier thing to achieve than any of these other things I was talking about with mobile rails. The more complicated version of this is wireless. The more complicated version requires us to get a whole bunch of ESPs and add an ESP in every single block. And at that point, when we connect them together, we're only connecting power cables. So instead of having the full bus connecting on those magnet ports that I was talking about, we only need power and ground to connect to power the ESP, to get the ESP up. And then once it gets up, then it can request to join the ESP mesh, and at that point they're all communicating. The impracticality of all this is that A, that is significantly more expensive to get ESPs for all these. B, the ESP is going to be significantly larger than simply having 2 shift registers on the board. It's going to be 2 shift registers plus the ESP, and the ESP is larger than both the shift registers combined. So, and on top of that, the ESPs need to communicate to each other back and forth when we are polling. Now, maybe each ESP pulls itself and then only communicates back to the master board when it has a key that needs to be pressed. So this guy is plugged into the USB. This is the only guy plugged into USB. And all the other ones send data packets over to it whenever they want to press a button. That may not be as difficult. However, again, getting ESPs into each one of these guys it's a little questionable. So finally, I say finally, I was going to suggest that I had more ideas, but honestly, I did not explore the other ideas nearly as much as I explored these first 3. Explored in terms of just thought about. But the third idea, and this breaks basically down into 2 subcategories, kind of like the other examples. But basically, we have our boxes, and we make them like a tool chest. So, let me grab that. We have connector rails, like that. I should have drawn that guy over a little bit more. You'll forgive me. And they connect together like that, and just like the previous examples with the linear rods or the long rectangular rod that I was talking about, rail I was talking about, the wires just connect through here. And basically, the designs I was looking at, this is actually the wrong drawing, so let me draw a better version. The designs I was looking at would have, I'll start out doing this first. 1, 2, and then 3 in this pattern. And this can be replicated indefinitely. So 2 from there, 3 from there, and then this top guy, in theory, could have a third one going all the way up here. So at that point, the wires coming out of this guy, when he dead ends, would just hop over to the bottom of this guy to continue up. These wires go all the way 1, 2, 3. Then they dead end and hop over to a third guy that again goes up there. So that's how that infinitely scales. It does have a similar problem to the other ideas like the cam one, where it keeps on getting higher and higher and you're getting more leverage out the side. The one benefit, however, is that we have these rails on both sides. So we have a whole bunch of support holding each layer up, which helps a lot. So that's where that one is superior. The sub-idea, the similar sub-idea here, is back to tool chests. I was thinking about it, and in theory, we can make half keyboards. So just assume that I'm copying this pattern here and go out both sides. So this one, and I say half, but basically this guy is worth 2, whatever size we decide to make this guy. These guys, the bottom guy is basically just twice whatever this guy is, and that way we can expand out. We get twice as many boards in half as much height. I say twice as many boards, but again, that assumes that this is an 8 keyboard, and then this guy is actually 16, right? And then this is 8, and that would be compared to 8, 8, and 8. And again, 8 is our maximum number on a shift register. So that is why I'm using 8 as the maximum here. So again, we get 4 boards right here, but we're only on the 2 board layer on this version. Problems with both of these, because everything that I've brought up happens to have a problem with it, right? In theory, you kind of want the USB board to be the bottom one, because you really don't want the USB running out the top like this, right? And that means that when these things are collapsed, the main board is actually buried underneath everything else. So that is a bit of a problem. In theory, back to we have this communication all the way up. We could include the USB lines all the way up to the top one. The problem, however, with that is that this version is going to have an interrupted data signal as these things are expanding out, because obviously each of those connection points at the base and top of the rail are going to rotate, which means that any connection points on those are going to rotate out of connection. If we had more than this, so right now, if you count this up right, for any single level pair, so this guy and this guy, or this guy and this guy, you have 4 total rails, 2 on this side and 2 on the other side. 4 is not 7. If we somehow had 8 total rails going in between layers, then actually that wouldn't matter. The only reason it matters is because presumably the connection points are something like here and here, and therefore when this is stacked up, this guy rotates up this way and this guy rotates down this way. So that's why this all ends up being a problem. But it's again, maybe we can make it work. I'm not 100% sure on that one, but maybe we can make it work. The reason I like this one particularly is because it does keep everything relatively compact, you know. If I had my choice on what to build, I actually would probably go for the ESP ones, just because that's cooler and it has less logistical issues in terms of mechanical things having to line up, because the Wi-Fi is always connected so long as the ESP is on. However, again, it becomes a little bit of an issue because each base is that much bigger. Each base could, in fact, be the master connection when you're putting ESPs in all of them. Now, I will recognize that you have your little ESPs and you have your big. So that's the low ESP. And then you have your big development board ESPs. I'm not 100% sure. I think these are 28s over here. I think these are ESP 28s. It's been a long time. I'm not entirely sure if these guys could connect to the ESP mesh. Then maybe that would be worth it. Maybe that wouldn't be as big of a deal because these guys are significantly smaller. But the fact of the matter is that it is still pretty costly. Significantly more costly than these guys. So that is just plain a consideration. And yeah, that's everything I got for right now. So I just want to get you guys caught up today. Again, we'll do some more designing. Well, we'll do some actual designing next time. The goal of today was just because it's been 2 weeks to get everything caught up and in order. I will make a decision on how exactly we're designing these by the next stream, and we'll get to designing them. And then after next stream, we're probably going to side shift onto one of these other projects that I got sitting around that I need to get done, just random design projects, and then double back to work on this some more. I'm hoping by the time we get done the next stream, I will then have stuff to do offline, which will justify, okay, I need to get that stuff done offline, so let's do a side project while we wait for that stuff to get done. Makes sense, right? So that is the plan moving forward. And yep, that's all from me. I don't think I have anything else to announce or any other plans to put into motion at the moment. It's basically just this and a couple side projects. So, as always, guys, thank you for watching, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you.